Quantitative ability, problems on pipes and cistern. Following are the parameters involved in this problem. The very first, C stands for the capacity of the tank, R stands for rate of filling or emptying, and N stands for time required to fill or empty. So C stands for capacity, R stands for rate, and N stands for time required. What relation we can build between these three variables? Rate of filling or emptying is equal to capacity of the tank divided by time required. R is equal to C by N, or N is equal to C by R, or capacity of the tank is equal to R multiplied by N. The topic of pipes and cistern is only based on these three variables. That's it. Let's start with problem number 1. A pipe can fill a tank in 16 hours. Due to leak in the bottom, it is filled in 24 hours. If the tank is full, how much time will the leak take to empty it? Now in this particular question, there is an inlet pipe or so-called filling pipe and outlet pipe so-called leak. So there is a pipe, there is a leak, and if both work simultaneously, I will write as pipe minus leak. Why I am writing here minus? Because the leak is doing negative work. It is removing water from the tank. Now the first variable I will write here as N. The value of N is given in the problem as 16 for the pipe. Pipe can fill the tank in 16 hours. So N is equal to 16 for pipe. And if pipe and leak both are working, then it takes 24 hours to fill the tank. So here I will write 24. We are supposed to calculate this value. In how much time the leak will empty the full tank. Another two variable I will write just below N as rate and capacity of the tank like this. So these three variables N, R and C to be written in vertical order like this. Now assume something as the capacity of the tank. Any value you can assume, but for ease of calculation we assume a number which is divisible by 16 and 24. Best way is to take LCM of this. So the capacity of the tank I assume as 48 liter. Anybody can assume any other value also, it doesn't matter. So if 48 liter is the capacity of the tank and the pipe can fill it in 16 hours, what is the rate of filling pipe? It is 48 divided by 16, that is equal to 3 liter per hour. And if both are working, it takes 24 hours. So here what is the rate of filling? 48 divided by 24, that is equal to 2 liters per hour. So pipe is adding 3 liters of water in the tank every hour, and if leak is opened, only 2 liters is getting stored in the tank here. It means what is the rate of leaking? Obviously 1 liter per hour, because 3 minus 1 equal to 2. So if 1 liter of water is leaking from the tank every hour, to empty the full tank, how much time is required? It is 48 divided by 1, which is equal to 48 hours. Option B. Problem number 2. Two pipes A and B fill a tank in 15 hours and 20 hours respectively, while the third pipe C can empty the full tank in 25 hours. All the three pipes are open in the beginning. After 10 hours, C is closed. In how much time will the tank be full? So in this figure we can see there are two inlet pipe or filling pipes and one outlet pipe. First of all, we will tabulate what data is given in the problem like this. There are three pipes A, B, C. जिसमें A and B are filling and C is emptying. The value of N is given as 15 for A, 15 hours for pipe A, 20 hours for pipe B, and 25 hours for pipe C. Then another two variables that I will write below N are R and capacity of the tank like this. Capacity of the tank, you can assume any value which is easily divisible by 15, 20 and 25. Best way is to take LCM of this. So I take capacity of the tank as suppose 300 liters. If anybody take any other value of capacity of tank, it doesn't matter. Your answer will be also finally correct. But something we need to assume here. Okay. So we assume the capacity of tank as 300 liter. In this case, what will be the rate of filling of pipe A? 300 divided by 15, that is equal to 20 liters per hour. What is the rate of filling of pipe B? 300 divided by 20, that is equal to 15 liters per hour. And what is the rate of emptying by pipe C? It is 300 divided by 25, which is equal to 12 liters per hour. Now let us do the calculation as mentioned in the problem. All the three pipes are opened in the beginning, and after 10 hours C is closed. So let us say A, B are filling pipe and C is emptying pipe. So what will happen in 1 hour? 25 plus 15, that is 35 liters of water will be added to the tank every hour, but 12 liters of the water will be drained out from the tank every hour. So net stored in the tank is 23 liters in 1 hour. And if this is going to continue for 10 hours, net stored in the tank will be obviously 230 liters. After that, pipe C is closed. Now out of 300 liters, 230 liters is already filled in the tank. How much is remaining to be filled? It is 70 liters. Who is filling this remaining tank now? Obviously pipe A and pipe B. And their rate is 20 and 15 respectively. So to fill 70 liters, they require further 2 hours. The question is in how much time the tank will be full again. The tank will be full in total 12 hours. For initial 10 hours and after pipe C is closed, further 2 hours. So option B is a right answer. Problem number 3. A tank has 3 pipes A, B and C. Pipe A and B can fill it in 8 hours and 6 hours respectively, while pipe C can empty it in 24 hours. Pipe A, B and C are opened respectively at 6 am, 8 am and 10 am on a certain day. By what time will the tank be filled? I request you to pause this video and try this question on the paper, and once you have solved it, you can again play the video to look for the solution. Okay, now let us tabulate it like this. There are 3 pipes A, B and C, in which A and B are again filling pipe and C is the emptying pipe. So we will write down the first variable n and the value of n for A, B and C like this. N is equal to 8 for pipe A, n is equal to 6 for pipe B and n is equal to 24 for the emptying pipe C. Now other two variable, rate of filling or emptying and capacity of the tank, I will write like this. Okay. First of all, we need to assume the capacity of the tank. Let us assume a number which is easily divisible by 8, 6 and 24. So I take the capacity of the tank as 120 liters suppose. So what is the rate of filling of pipe A? 15 liters per hour. Rate of filling of pipe B as 20 liters per hour, and rate of emptying by pipe C as 5 liters per hour. Now pipe A is opened at 6 am and pipe B is opened at 8 am. Let us see the progress of filling from 6 am to 10 am. What will happen in the span of 4 hours, that is 6 am to 10 am. ये 4 घंटे में pipe A is working for all 4 hours while pipe B is working only for 2 hours because वो 8 बजे चालू किया था. So pipe A has added 60 liters of water because it is working for 4 hours from morning 6 to 10 and it is adding 15 liters per hour. So 4 घंटे में 60 liters पानी add करेगा. जबकि पाइप भी 2 घंटे ही काम कर रहा है एंड इट इज फिलिंग एट द रेट ऑफ 20 लीटर्स पर आवर. सो पाइप बी ने कितना पानी ऐड किया? 20 मल्टीप्लाइड बाय 2 दैट इज 40 लीटर्स. इसका मतलब आउट ऑफ 120 लीटर्स 100 लीटर्स ऑफ वाटर इज फिल्ड इन द टैंक. अभी 20 लीटर भरना बाकी है. नाउ द थर्ड पाइप which is called emptying pipe C is also opened. So we need to find out to fill remaining 20 liters how much time it will take. Time required to fill remaining 20 liters is equal to 20 liters divided by filling rate that is 15 plus 20 minus emptying rate that is 5 because pipe C भी चालू कर दिया. So that will come out to be 2/3 of an hour, so called 40 minutes. So 10 बजे के बाद और 40 मिनट लगेंगे to fill the tank. Hence the tank will be filled at 10:40 am. Option B. Problem 4. 3 pipes P, Q and R can fill a tank in 6 hours. If all are open for 2 hours and then R is closed, the P and Q can fill the remaining part of the tank in 8 hours. In how many hours R alone can fill the tank? Now in this particular question, there is no negative work. There is no leaking pipe. There is no outgoing water. All three are filling pipes only. So we will write P plus Q because ultimately what is happening, P and Q are filling the remaining tank together. So I will write P plus Q and R separately like this. And when all three are working, it is P plus Q plus R. The first variable N is given here as 6 for P plus Q plus R. When all three are working, the tank is filled in 6 hours. Other two variable rate and capacity I will write below like this. Now capacity of the tank you assume any number either 6 or in multiple of 6. Let us assume anything, let us say 60 liters as the capacity of the tank. Anybody can assume 24 liters, 48 liters, 120 liters, whatever you want. I assumed it as 60 liters. So what is the rate of filling of P, Q and R together? It is 10 liters per hour. Now we will do the calculation as mentioned in the problem. If all are open for 2 hours, so if all three are working for 2 hours and the rate of filling is 10 liters per hour, how much water is added? P, Q and R into hours, they will add 20 liters of water. So out of 60, 20 liter got filled. How much is remaining to be filled now? Obviously 40 liters is to be filled. Who is filling this 40 liters? Pipe P and Q is filling that 40 liters. In how much time? It is said that pipe P and Q is filling the remaining tank in 8 hours. From this, can we calculate the rate of P and Q together? Yes. 40 लीटर पानी P और Q 8 घंटे में भरते हैं, तो what is the rate of filling? It is 40 divided by 8, that is 5 liters per hour. So I can write in this table here rate of P and Q together as 5 liters per hour. So all three pipes can fill 10 liters in 1 hour, जिसमें P and Q can fill 5 liters per hour. So what is the rate of R alone? Obviously it must be 5. Now the question is, in how many hours R alone can fill the tank? 60 liters if to be filled at the rate of 5 liters per hour, it takes total 12 hours. 60 divided by 5. Option C is the right answer. Problem number 5. A tank is full of water. A drain pipe which can empty the full tank in 60 minutes is opened. 18 minutes later, another pipe which can fill the empty tank in 30 minutes is opened. After how much time in total is the tank full again? Now there is a filling pipe and there is a drain pipe. The value of N is given as 30 minutes for filling pipe and for drain pipe it is 60 minutes like this. The other two variable rate and capacity I will write below like this. And capacity of the tank we will assume a number which is divisible by 30 as well as 60. Let's take it as 60 liters. So what is the rate of filling? 2 liters per minute, and rate of leaking is 1 liter per minute. Now as per the problem, the tank is initially full. So the initial condition is like this, the tank is full with complete 60 liters. Now the drain pipe is opened for first 18 minutes. How much water it will leak out in those 18 minutes? Obviously 18 liters. The drain pipe in 18 minutes will take out 18 liters of water. How much water is remaining in the tank now? 42 liters, because out of 60 liters, 18 liters gone. After that, the filling pipe is also opened. जैसे 18 मिनट हो जाते हैं, filling pipe चालू कर दिया जाता है. We need to find out बचा हुआ 18 लीटर पानी जो चला गया था वो कितने देर में फिर से भरेगा. That can be found as 18 divided by 2 minus 1, as 2 liters is coming in the tank every minute and 1 liter is going out of the tank every minute, because drain pipe बंद नहीं किया गया, वो अभी भी चालू है. So net stored in the tank is 1 liter every minute. So 18 लीटर भरने के लिए 18 मिनट लगेंगे. Now the question is, how much time in total is required to fill the tank again? Time in total. So पहले के 18 मिनट और अभी फिर से जो लगे 18 मिनट, वो that is 18 plus 18, 36 minutes should be the answer. Option C. Problem number 6. A tap can fill the tank in 20 minutes. A leak can empty the full tank in 30 minutes. At first, tap is opened. Then after some time, leak is opened. After how much time should the leak be opened after opening the tap, so that the tank gets full in exactly 30 minutes? So there is a filling tap and there is an emptying leak. The value of n is given as 20 minutes for tap and 30 minutes for leak, like this. The other two variables R and C I can write below it. The capacity of the tank, we can assume any number which is divisible by 20 and 30. Let us take it as 60 liters. So what is the rate of filling of tap? 60 divided by 20, that is 3 liters per minute. And what is the rate of leaking? 60 divided by 30, that is 2 liters per minute. Now we need to fill this tank in exactly 30 minutes. अगर हम लीक को ओपन नहीं करते तो टैप उसको 20 मिनट में ही भर देगा. As it is said here, tap can fill the tank in 20 minutes. But we need to fill it 30 minutes. In this 30 minutes, tap is working for entire duration 30 minutes. So ये 30 मिनट में टैप कितना लीटर पानी ऐड करेगा टैंक में? Obviously 30 multiplied by its rate, that is 90 liters of water. Now the question is, can the tank hold 90 liters? No. The tank can only hold 60 liters. इसका मतलब जो एक्स्ट्रा 30 liters पानी आ रहा है वो अपने को ड्रेन आउट करना पड़ेगा. We need to drain extra 30 liters of water. Now what is the rate of draining or leaking? 2 liters per minute. So 30 लीटर पानी बाहर निकालने के लिए लीक को कितना देर चालू रखना पड़ेगा? That can be found as 30 divided by rate of leaking, that is 2, which will give you 15 minutes. इसका मतलब लीक पाइप को अपने को 15 मिनट चालू रखना पड़ेगा. So if I consider the entire span of 30 minutes on the timeline when the tap is opened and tap is closed, in this 30 minutes, the leak pipe need to be opened for 15 minutes. So if I consider the last 15 minutes where leak pipe to be opened, we can answer this question. जहां पूछा गया है, after how much time should the leak be opened after opening the tap so that the tank is full in exactly 30 minutes. So tap चालू करने के 15 मिनट बाद you should open the leak so that the tank will get filled in 30 minutes. The answer is option C, 15 minutes. Problem number 7. Pipe A can fill 12 liters per minute and pipe B can fill 6 liters per minute. Pipe C can empty a cistern in 10 minutes. If all the three pipes are opened, the cistern is filled in 15 minutes. What is the capacity of the cistern? Now this is the question where capacity of the tank is asked to you. So there are again two inlet pipes A and B जिनका rate of filling आपको दिया है 12 liter per minute and 6 liter per minute. और एक emptying pipe है जिसको pipe C नाम दिया है, which can empty the entire cistern or tank in 10 minutes. Okay, so we'll tabulate it like this: A, B, C and A plus B minus C. The value of N is given for C, and if all three are opened, that is A plus B minus C, as 15 minutes. So I will write the value of N as 10 and 15 for this. The rate of filling is given for pipe A and pipe B as 12 liter per minute and 6 liter per minute, which I will write here. We cannot assume the capacity of the tank here because that is something which we need to find out in this particular question. Okay, so let us assume the capacity of the tank here as X liter, which is unknown value, and we need to find it out. So what is the rate of C? Obviously it will be X divided by 10. And what is the rate of A plus B minus C? It will be X divided by 15. So rate of A plus rate of B minus rate of C is equal to X by 15. So this is your equation. If you solve this equation, X can be found as 108 liters. That is the capacity of the tank. I hope you understood the concepts of pipes and cistern. Thank you for watching this video.